Hello and welcome. Today our topic is going to be the logarithm laws and properties. But before we get to that, I want to go over some review questions on evaluating logarithms. For these four problems, we're going to try to determine what they are equal to. We're going to start with log base 3 of 9. So we're not sure what exactly it's going to be equal to yet. We know it's going to be 3 to some unknown power is equal to 9. Well, if we think about that for a second, we would figure out that 3 squared is equal to 9. That means that this logarithm is going to be equal to 2. In number 2, we're looking at log base 5 to some power is going to be equal to 625. Now, that's a large number, and you might need a calculator to help you, but you would eventually figure out that 5 to the fourth power is equal to 625. That means that 5 to the fourth power is 625, and log base 5 of 625 is equal to 4. Then we look at problem 3 is a little bit more challenging. Well, we have a fraction. So 6 to some power is equal to 1 over 6. If we write that 6 as having a little 1 exponent above it, we could think about it as 6 to some power equals 1 over 6 to the first. Well, if we move that 6 to the denominator, that usually means we had a negative exponent to start with. And that means that our answer is 6 to the negative 1. And that means that our answer for this problem is negative 1. Log base 6 of 1/6 equals negative 1. And finally, we're looking at log base 4 of 2 equals blank. Now, this is a little bit harder than even number 3 because you're going downwards. And whenever you go for exponents to smaller numbers, that means you're using a fraction exponent. And it turns out that 4 to the 1/2 power is equal to 2. And this logarithm is equal to 1/2. The key point here is remembering that 1/2 power and square roots are exactly the same thing. We can write it as the square root of 4 is equal to 2. So now next we're going to be starting to talk about logarithm rules and properties. Now that we have finished evaluating some review problems, let's think about the logarithm laws and properties. First things first, we want to consider two evaluating problems, like log base 5 of 5 and log base 3 of 125. Well, if we have log base 5 and things are multiplying by 5 any number of times, we want to think about how many times you would need to do that to get to 5. Well, that answer is 1. 5 to the power of 1 would equal 5. And that means this first logarithm would be equal to 1. In the second problem, we have log base 5 of 125. Well, if we need to multiply it by 5 a certain number of times, we would need to do that 3 times to make it to 125. So we can say that this logarithm is equal to 3. We've already seen our first law. So if we look over here, we're going to write out our laws. Our law number 1 is that log of any base we want, A, of the same number is going to always equal 1. Just like how we saw that log base 5 of 5 equal to 1. Well, 5 to the power of 1 equals 5. We could say log base 8 of 8 is equal to 1. We could say log base 16 of 16 is equal to 1. Anything to the power of 1 equals itself. So log base A of A is always equal to 1. Our second logarithm law slash property that we're going to be looking at will involve both of the problems we just did right here, as well as problem number 2 from our warm-up evaluating practice. So let's look at what we have in these two problems. So if I took those two logarithms and I wrote log base 5 of 5 plus log base 5 of 125, that would be the exact same thing as writing 1 plus 3. I already know that log base 5 of 5 is equal to 1, and log base 5 of 125 is equal to 3. So since this down here obviously equals 4, well, that means that this also equals 4. So we've determined just using basic arithmetic that log base 5 of 5 plus log base 5 of 125 is equal to 4 because their answer is 1 plus 3 equals 4. Next, we have to look at the problem back up at the top. We can see the log base 5 of 625 equals 4. We know this logarithm addition also equals 4. So based on that, well, if both of these added together equal 4 and this log base 625 equals 4, well, that means they're equal to each other. So I could take that logarithm. We have log base 5 of 5 plus log base 5 of 125 now equals log base 5 of 625. This we know equals 4. 5 to the 4th power equals 625. 5 to the first power equals 5. 5 to the 3rd power equals 125. And we could even draw some arrows in to show each of these are matching up with what they're equal to from what we already did earlier. So now all we have left to do is think about how they relate to each other. We have the log base 5 of 5. We have this 5. All these are 5s as bases. So we just have to see, like, well, how can I relate 5 and 125 to 625? If you give that some thought right there, well, you would figure out or maybe remember that 5 times 125 is equal to 625. And we could rewrite this same thing as log base 5 of 5 plus log base 5 of 125 would be the same thing as log base 5 of 5 times 125. We can even be more specific, and we could say that we can kind of circle the 5 and circle the 125, and that ends up in the same, in one logarithm, kind of condensed together to the 5 times 125. Let's check this property to see if it's holding true for other examples. So if we look back up at the top, we have a problem that was log base 3 of 9 is equal to 2. So now let's use that. We know log base 3 of 9. I know the answer to that was 2. Let's say we wanted to add that to another logarithm, like log base 3 of 27. And based on the rule that we just saw above, if we have the same base, 5 and 5, here we have a 3 and a 3, we did 5 times 125 equals them multiplied together, or 625. So we have to determine if this is equal to log base 3 of 9 times 27. 9 times 27 is equal to 243. Let's try to prove that to ourselves. Well, if we think about the answer to log base 3 of 9, well, we know already from the top that that is equal to 2. What about this next one, log base 3 of 27? Well, if we're multiplying by 3's, we would need 3 of those 3's to get up to 27. So that means log base 3 of 27 would be equal to 3. And lastly, well, if we just do this on its own, we have to think about how many 3's you would need to get up to 243. And so we can just grab a calculator real quick and check that out. And so we can try that out and just do, well, let's try 3 to the 4th. Oh, well, that's not big enough. 3 to the 5th. Perfect. 3 to the 5th equals 243. So that means that log base 3 of 243 is equal to 5. Well, we all know that 2 plus 3 is definitely equal to 5. And so that means that, yes, check. We know that it is equal, and those two are equal to each other. Log base 3 of 9 plus log base 3 of 27 is equal to log base 3 of 243. And just to be a little bit more clear, we could even write that 9 times 27 over here equals 243. Our work here means that we have a second law to go with law number 1 that we wrote up here. So our second law is going to be log base A of some random number P plus log of the same base A of some random number Q is going to be equal to log base A of P times Q. And that is 2 of our logarithm laws that we will be learning about. And we will continue learning about logarithm laws in our next video.